Welcome back, my friends. In today's video, I want to show you how to build a dashboard like this. You know, it's a typical data dashboard that just shows a couple of key values for the data that you have. Here we currently have a penguins data set that shows us different kind of statistics for penguin weights or for other measurements for penguins, and that's the kind of thing we want to build today. And not only that, I also want to show you how to bring this stuff online, so how to deploy it, and also how to automate this deployment process to make it really easy to deploy new changes. So with that said, let's dive in. To dive right in, let's take another look at our dashboard. You know, just so that we have a feeling for the thing that we're going to build. You see, this is a simple dashboard and it starts with the first tab called All Static. And as you go through the tabs, it progressively becomes more interactive. You see, in the all static version, there's nothing I can click or do. It's just a couple of pictures and that's it. And as I go through different tabs, for example, for interactive table, I can start to sort the rows. And for example, I can hover over charts to see different information. And as I go even further, there come value boxes. And on the final tab, I also have a drop-down menu. I do have a sidebar that I can collapse, and I can change which penguins are seen inside of this chart down here. So this is a dashboard that has some light interactivity, but the nice thing about this is that this is still considered static. All of the things that you see here were pre-computed and are not recomputed at runtime. So as I click on, for example, this filter here, this thing here is immediately displayed differently, but nothing is completely recalculated. The penguin statistics are not recalculated by some server in the background. And this is what makes it really easy to deploy this kind of thing. It's also a limitation, but in a lot of scenarios, you can get away with these limitations and just build a nice looking dashboard that display your key statistics. So now that we got a feeling for the thing that we want to build, let's also talk about the underlying architecture that we're going to use here. And while architecture sounds really complicated, really what I mean here is the things that we're going to use to stick together to form this whole dashboard building and deployment process. So here I've sketched out the things that we are going to do. We will have data in some online storage. This could technically be a database or an AWS S3 bucket or some Azure Blob storage, whatever you have. Then we're going to build the dashboard using that data, using our favorite data science language. This could be R, Python, Julia, or Observable.js. And once we have the code for that, we can stick this into a Quarto document that can handle these kind of different languages and will weave the code chunks together into one dashboard. So once we have these rendered Quarto dashboards, what we're going to do is to publish the dashboards online. We could do this on GitHub Pages or Netlify or some other place where you deploy your static websites. Here in this video, I'm just going to use Netlify. And once we've understood how this process works, we can orchestrate this whole process and automate it using GitHub Actions to run all of this inside the cloud. So that's what we want to do today, and as you've seen, there are a lot of different moving parts in this. So naturally I won't be able to go into each and every part in detail, but don't worry, for all of these parts that you might be unfamiliar with, I have already created a different video and I'll link to that as well. So that way you can get a lay of the land, figure out how to create this overarching picture. And once you want to learn more details, you can look into the corresponding video for the stuff that you still need to learn. So with that, I think we're set. So let's start with the dashboard. So as I said, we're going to build the dashboards using a tool called Quarto. It's a fantastic tool that I think every data scientist can use because it allows you to mix code chunks with text and create all kinds of different output documents from that. If you've never heard of it before, you can check out quarto.org and take a look at a couple of these examples here and see how the same tool works for all kinds of different languages depending on what data science language you use. And once you've installed this for your computer, you can also install the Quarto extension for, say, VS Code or Positron, and then you can render Quarto documents. And it's really simple. You can just put in some text. That's a clever text, I guess. And then you can throw in code chunks. And here I'm going to throw in an R code chunk, and then I'll just say 1 + 1. And I could technically execute this thing here, and I'd see the output in my console. But what I can also do is to render this thing by pressing Ctrl+Shift+K with the Quarto extension. And then you see that it will generate a website for me. But that's really not what we want here. What we want is a dashboard. I mean, it will be a website, but we want to have it in a particular format. And that's why we can, inside of the Quarto header, say that the format is supposed to be dashboard. And now if we re-execute the same thing, we see that, okay, it has thrown in still the same text, but now it only shows me the output of my calculation here. And if I throw in multiple code chunks and re-render this, then we see that we now have multiple of these cards here. And Quarto allows you to make these things look a little bit nicer by this triple colon notation, where you say that this is a card. You close the colon here. So basically this thing here will become one card. And then you could also specify a title like, so, hey, this is a title. And now if we re-render this, we see that, okay, this became a card now with a title in here. And if we replicate this thing here, we have 3 cards, and depending on what you put into these code chunks, you can have all kind of different content inside of these cards, and Quarto will arrange these things for you into a grid. Example, if I throw in a markdown headline notation here and then put in some text, the text actually doesn't matter. It's just that the notation is there so that Quarto understands, okay, this part will go onto a new row. So I could also technically call this row. And you see that things were now arranged on a grid, and that's how you can really easily create a dashboard. Of course, you probably don't want to have a random text in here, so let's throw this out. So hopefully you get the idea that Quarto allows you to mix code outputs with some special markdown notation, and it will weave this together into a dashboard. And again, you can use R code chunks here, or Python code chunks, or observable.js code chunks. It doesn't matter, it will still work the same. And if we look into the Quarto file that I've prepared for this dashboard and render this, then you see that it will take longer because I've already filled it with much more content, and so therefore there will be more calculations. But the moment they're finished, we can go through all of the pages that we have seen earlier. But the difference is that right now this is not on the internet, it isn't deployed anywhere, but instead it still just lives on my machine. And if we look at this Quarto file a bit more, we see that, okay, here I've just included a couple of other Quarto files. And if I open one of them, say this file here, you see that, okay, this is just the same thing we have seen before, a couple of code chunks mixed with row notation, mixed with these cards, and mixed with more code to actually display something nicer. So here you can see that in this card title look penguins data, on this interactive chart tab, you see that, okay, this is the card we have here. All cards by default are able to go full screen, and we see that we have a table here, and the code for this table is this thing here, which has just a couple of helper functions. This is why this code chunk has the context set up so that the output doesn't go anywhere. And then in the next code chunk, we see that this generates a table, and this is the exact table that we see here. So that's kind of the idea behind Quarto dashboards. You just throw together a couple of code chunks, and Quarto will rearrange those on a grid for you. And for the more interactive stuff that we see here, like these toggles or this slider here, we can also have a look at the code. And if we look at this code, it is in the OJS plot file, and there we have used JavaScript, OJS, observable JavaScript code chunks to calculate these things, because observable.js allows much more interactive feeling than what R or Python allow you to do. So that's kind of the specialty here. If you want to have more details on how to build this dashboard, I have a dedicated video for just building this thing, writing out the Quarto and R code. You can check it out via the link in the description, or there should be a link popping up right about now. But with this idea out of the way, let's move on to how to actually integrate data sources from some online storage into our dashboard. But before we do that, let me mention that if you enjoyed this video, make sure to give this video a thumbs up so that I know that you enjoy this kind of content. And also, if you want to learn more stuff about this, I have recently written a PDF guide that shows you a whole bunch of things that you can learn within the modern R ecosystem, and it will give you a guide through this whole ecosystem. So it's a great resource if you want to get an overview of what the modern data scientist needs to know nowadays. And if you're interested, you can follow the link in the description and download the PDF that way. So now with that out of the way, let's get back to the video. So now that we have this dashboard generation thing out of the way, let's talk about the step that comes before that, namely getting our data into Quarto basically, or rather into our programming language of choice. And for that we have multiple options. Here I have just thrown in a couple of these typical storage logos like a Postgres database or AWS S3 or Azure Blob Storage, but in principle the idea is always the same. You see, at some point inside of your Quarto file that you use to generate a dashboard, you just have to include a code chunk to actually download the data. And thankfully there are packages that make that really easy. For example, here in this code chunk, this is really all that happens to get the data from the online storage, and then the rest of the dashboard code can just use the data frame that we have downloaded here. So if I execute just this part here, we see that everything executes fine. And if I take a look at this df penguins variable, you see that it has our penguins data set, and this is the data set that all the other pages from our dashboard uses. So all of these other pages that are coded inside these other Quarto files can just use this df penguins data frame, because this code chunk is executed even before any of these other files are included. So that's really as easy as it gets. Just create a code chunk that loads your data from the online storage. And here I have used the pins package, which is available for R and Python, that allows you to really easily get data from typical cloud storages like AWS S3 or Azure Blob Storage. And the idea is pretty simple. You just have to, from the pins package, load one of the many board functions. So if I take a look at the pins package, you see that there are many board functions like Azure or Connect or Databricks or wherever else you might want to store your data. And then you just have to specify at which bucket, because I'm using an S3 bucket here, at which bucket my data is stored, in which AWS region it is stored. And then you will just have access to this board, which is really just a collection of references to everything that is stored inside of your bucket. And inside of these boards, you have so-called pins that actually store the data. And this is why you take your board and pass it to the pin read function that will read the pin with the name penguin new. And this is the data set. Really, that's all there is to it. But of course, I went through this kind of quickly. If you want to learn more about the pins package to figure out how to work with these online storages that just store data, then you can check out this video here, like the link that pops up right about now, or there. Again, I always forget in which side the link should pop up. But my point is, there is a video about the pins package that shows you how to really easily work with it. And also it shows you its really cool built-in features like data versioning. But that's not what I want to focus on here. So let's move on to the next thing. And the next step is to actually publish this thing. And to publish this thing with Quarto, it's really easy. What you have to make sure of is that your directory you're currently working in is actually a Quarto project, not just a single file like we have created here, but actually a Quarto project. And there's really nothing too fancy that you need for that. All you need is a file called _Quarto, and in there you just throw in some YAML specification that you're currently using a website. And as a specialty, I'm saying that it's supposed to only render the index files, because all the other files will be rendered once everything is stuck together inside of this index file. And that's it. I also do have a couple of formatting specification here just because I think it's nice, but that's totally optional. But the moment you have that, you have a Quarto project, and what you can do then in your console is to call the Quarto publish function. And what it does is that it will say, okay, where do you want to publish? In my case, since I've already published this thing, it will ask me, hey, do you want to update that? But I could also say, to show you how you could publish your new project, I can hit on add a new destination, and then I could also still choose Netlify or something else. Let's just do Netlify, and then it will ask me, hey, can I connect to your Netlify account? I'll say yes, and then it will try to ask for my permission to start a new Netlify website for this. I don't want to do that here, so I'll click deny, but in your case, you could just click authorize. and then Quarto will handle everything for you. So here I'm doing deny, and then I close this command and instead redo everything and say, okay, let's just publish this at the current address, and I'll say yes. And now it will still ask me, hey, can I publish this? And I'll say, yeah, go ahead. And then you can see that inside of my console, everything is rendered, the output is generated, and then everything is uploaded. And it even shows me that everything started out well. And then I can click on the link, and I see now that my thing here, my dashboard, it currently lives online. This is a URL that you could actually call, and you'll see this exact thing. And also you'll see that the last updated timestamp I have here is updated. So that way I can see this is the most recent data version. Since my data set doesn't change over time, it doesn't make any sense to use it here. But for you, if you have a use case that has updated data, say like every hour or so, then you could rerun this thing every hour, write an automation for that, and then you'd always see, okay, this already updated like last hour, or if it updated like 5 hours ago, you know that, okay, something is up, you should check what's going on there. So that's why there is this last updated timestamp here. But here it also serves us well to show us that we actually did something. So now comes the question, how do we automate this? And if we take a look at our architecture again, we now see that we have covered everything from online storage over dashboard generation to deployment. And what's left is the overarching orchestration part, and this is where GitHub Actions comes in. And the way GitHub Actions works is that you first have to make your project into a Git repository. That's probably something you should always do, so I kind of expected that this was already the case. And then once you have that, you can, inside of your directory, let me collapse everything here, you can create a directory .github, and in there create a directory called workflows, and in there you can specify a YAML file. You can name it whatever you want. I've called it deploy YAML, and if you open that, this is where you need to specify the deployment process on GitHub Actions. If you've never done this before, this feels super complicated, but don't worry, as I've said, I've got resources for all of these scenarios. You can get the whole details about GitHub Actions in a different video. Here I'll just skim through the idea of what this YAML file is supposed to do. You see, the idea behind such a YAML file is to specify actions that you can first name. Here I've called it render and deploy to Netlify. Very generic name, you can throw in whatever you want. Then you have to specify conditions when this action is supposed to be triggered. On GitHub, you can do stuff like whenever something is pushed to my main branch, or whenever there is a pull request to the main branch, then trigger this action. Or you could also say, run this on a schedule. In this case, this cron job notation means run this at every 15th minute. So basically every 15 minutes, this thing will get redeployed, or this action will get re-triggered. And then you have to actually specify, okay, what is supposed to happen inside of this action. And this is where the jobs come in. And here we just define one job. This thing has only one job. It is supposed to run this job on a machine. That might feel weird at first, but if you think about it, GitHub Action runs in the cloud somewhere, and it is supposed to re-execute all of the code, all this Quarto rendering that happens on your machine when you, say, press Ctrl-Shift-K on this index Quarto file, and then you see that there are a whole bunch of calculations running until the dashboard is generated. This needs to happen somewhere, right? And therefore, GitHub Actions will also need to provision a machine to run this thing. And this is where this YAML file specifies. Let me actually get rid of this part here, make this a little bit narrower. And this is why GitHub Actions needs to provision a machine. In this case, we say run this on an Ubuntu machine in the latest version. That's just a name. And then you can specify, okay, what kind of steps are supposed to run on this machine. And for a whole bunch of typical actions, there are already other actions defined for you that you can just use. For example, to check out the most recent version of this current repository, you can use the checkout action. Then, because on the machine that GitHub uses, R isn't necessarily installed, you will have to install R. You don't have to figure out a way to do that. You will just use this setup R action from the rlib community. And then you'll have to install some other things like packages. Here I make my life really easy by first installing the system dependencies for the package, because this pack package is kind of hard to say, pack package, but my point is with this pack package, you can really easily install packages, and it will also handle all kinds of system dependencies that your package might need. If this doesn't mean anything to you, just remember that pack does a whole lot of nice things for you, and that's why we need to install it on this machine that runs in the cloud. And for that, this machine needs to have the programs installed to run pack, and this is where we first install a couple of system dependencies, and then we run R code that just says, okay, install this renv package, and then restore all of the packages that we have inside of our log file. And inside of our log file, we have defined all of the packages that we need to run our code successfully. And because inside of my R profile file, I've set renv to use pack, we know that this renv restore command will be executed using this nice package installer pack that we have installed before. And then we know that once this step here concluded, all of the packages are installed, everything should be done. And then we have to install Quarto on the machine. This is again where we can rely on a nice action from the makers of Quarto. They have created an action called setup. We can just use it using this predefined YAML code chunk, and then we need to call this Quarto publish command, and for that there is also this publish action that can publish to Netlify. All you have to do is specify the target, which is Netlify, and then you have to specify all of the credentials that are required to run this thing. There are credentials required to get the data from AWS S3. I have them on my machine, so this is why this code previously worked, but on the machine on GitHub, you will have to store these in some secrets so that this action can later on use this. And also when I called Quarto publish earlier, so when I did Quarto publish, remember that we were asked to authorize to open the browser, and then we were asked to authorize this whole deployment process. When this thing runs on GitHub in the cloud, we can't really authorize anything. So this is why we have to get a specific password that tells Netlify or Quarto that everything is already authorized. And this is exactly what this auth token is. And you can create such a token by looking inside of Netlify for auth and then going to OAuth applications. And if you do that, you will also find something like personal access token. And this is where you hit on the new access token button and you'll get a new token that you can then store inside of GitHub. Again, more details are inside of the GitHub Actions video, but in principle, this is how you then authorize this GitHub action to publish stuff for you. And once all of that is set up, you just have to push this YAML file to GitHub and you'll have a nice GitHub action. So for example, if I were to just commit everything that I have here, some of these dummy files I've created and changed, I will just commit all of them. Let's just call it demo, and then we can publish this or push it to GitHub. And once we look into our repository and reload it, we see that our demo commit created a new action or triggered a new action. And then we can look into our build deploy and we see that here all of our steps are currently running. Currently it's installing R on the machine. And similarly, once that is finished, it will jump to the next step and so on. And it will install everything we need, or it will do all of the things we've defined inside of this GitHub action. And as you can see here, the last step is to render and publish all of the things that we have created inside of our Quarto dashboard. So that's kind of the gist of it. That's the overview. Again, for all details, you can refer to the specific videos. There will be links for all of this in the description of this video. Hooray, and now everything finished installing. And if we go to our website from before, let's take a look at this last updated timestamp. And now if we refresh the page, we see that this last updated timestamp changed. Notice that here the hours also shifted by 1. And this isn't because this video is so long. I haven't been recording for 1 hour. The reason why this happens is because the machine on GitHub is by default using UTC time. German time is 1 hour ahead, so this is where this 1 hour time difference comes from. And with that, we have completed our whole project. I think it's a really nice setup because it allows you to really easily deploy these kind of simple data dashboards. And even better, once you have an automation set up to re-execute this, say every 15 minutes, you just have to lean back And as the data on your online storage updates, your dashboard will soon after also be updated due to the time schedule. So that's a really neat setup, and in a lot of scenarios you don't need more. So I hope you get a whole bunch of value out of this video. Let me know in the comments if this was useful for you. Also remember to give this a thumbs up, and don't forget about the free PDF guide and the other videos I have in store for you. So with that said, I say thank you for watching, and I'll see you next time.